Hey, welcome. Today we are going to be graphing linear relationships, most of which will be in y equals mx plus b form. So I want you to just start. I want you to pause and do these steps by yourself and see if you can write the equation for the line. And remember, the equation is going to be y equals mx plus b. So you have to find your y-intercept and your slope. All right, pause and continue when you are finished. All right, so this is my not perfect line. So I started at 0, -3, right here, and then it said to go up 2 and to the right 1, up 2 to the right 1. But I also know that I can do the opposite and go down and back, down and back. So I plotted those points, and now I have to write the equation. So remember that our B is where we begin on the y-axis. So on this line right here, where's the point? It is at -3. So y equals whatever your slope is, x, and then whatever your b is. So now we have to find the slope. Well, since we went, the slope, remember, is the rate, and it is how it goes up, or the rise. So it's that ratio of rise to run. It's the ratio of how your dependent variable is changing to the independent variable. It's the ratio of the y change over the x change. It is so important that you remember that it's dependent to independent. Order matters. So we went up 2 over 1, so it is 2. That's the equation. All right, so one of your concepts is graphing from a table. So we have to make a table and from a story. So let's read the story. You're going to the ball, no one wants to drive you, you have to take a taxi, and they charge 50 cents a mile. So it says figure out the fare if you live. So at 0 miles, it was 0, but at 1 mile, it was 50 cents. And at 2 miles, it was $1, etc., etc. Please take a moment to finish the table and number your axes and see if you can pull out the y-intercept, the slope, and then write the equation, and then come back. All right, so this is what I had, and please be careful that you look, instead of just glancing at this and saying, oh, I'm wrong because my line doesn't look like that, look at how I numbered the axes. I actually kind of cheated a little bit because I wanted to spread it out. So I actually didn't get that 6th one on there. I only went to 5. And I skipped numbers here just to spread it out a little bit. So that's what I did. If you numbered differently, your graph might be tilted a different way. This is how mine is tilted. Okay? So my y-intercept, it went through 0. My slope, well, we know that the slope is that rate of change, so it is 0.5. We're going 0.5 per mile. So for 1 mile, it was 50 cents. For 2 miles, it was $1. For 3 miles, it was $1.50. We can't just count the boxes, although in this case, because I numbered my axes the same way, it does work out to be up 1 over 2. If I had not numbered it the same way, though, it would not have worked out. So, because my y-intercept was 0, I don't have it here, and I could have written the 0.5 as 0.5 or 1/2. All right, this is the same exact question, except this time, at 0 miles, you get charged $3 just for picking you up. So again, do the same thing. But this time remember that your initial cost is $3. Okay, so let's examine this one. So I filled out at 0 it was $3, and then I went up 0.5 every time. So my table is filled. And then from the table to the graph, I could just plot the points. So I did. At 0 it was 3, at 1 it was 3.5, so in between. At 2 it was 4, etc., etc. So when I'm looking at the graph to get the y-intercept is 3, and I was going up 1/2 for every one. And so in this case, you can't count the boxes because you went up one, it looks like you're going up 1/2 for 2, but because this is 1 and I numbered this differently, we have to look at our numbers along the axis. So this is my equation. So if you're following along in notes on the PDF, I did skip a couple slides. You can try to do those on your own, or maybe you should do those on your own and then come check them with me. But really, if you understood the first 2 slides, you could probably skip those 2. So we're going to go to this one, graphing from the slope-intercept form. So I want you to remember the m is the slope or the rate. It's how you move. The y-intercept is your beginning on the y-axis. So to graph without a story, you're just going to pull out your y-intercept and the slope, plot the y-intercept, and then use the slope as the driving directions to move to the next spot and repeat a few times. It sometimes helps to define the slope, which I'll talk about in a minute. So let's pull out our information. So my b is, remember, the one without the x. So my b is 3. And my slope is the one with the x, and it's how I'm moving, so it's 2. So then it says, now I am going to assume that these are, because the numbers are low, I don't have to change my axes. I don't have to renumber them. I used to make everybody renumber, but it takes so long. So right now we're just going to leave it like this. If you are not doing intervals of 1, you have to number though, okay? So we pulled out the y-intercept and the slope. Now I'm going to plot the y-intercept. It's 3, so I'm going to go to my y-axis, and I'm going to go up to 3. 1, 2, 3, and I'm going to put a point. Then it says use the slope as the driving directions. So we need to define what 2 means for the slope. If it's rise over run, remember we need the rise and we need the run. So 2 over 1 is 2. So this means I'm going to go up 2 and to the right a positive 1. Or I could reverse that, because negative divided by a negative is also a positive. I could go down 2 and back 1. So from this point I'm going to go up 2 over 1, up 2 over 1, or down 2, back 1, down 2, back 1, down 2, back 1. And if you are doing this on paper, you really need to use a ruler. But I'm just going to free draw it right now as carefully as I can. And there you go. Okay, I want you to try to do this one on your own. Remember, you're going to start by pulling out your y-intercept and the slope and see if you can graph it. Okay, so let's examine this one. So here, I'm hoping you didn't drop the negative. It was a -3, so we needed to go to -3 here. And my slope was 1/2. And then I defined how I'm going to move. Since it was 1/2, I could go +1 up, +2 over, or I could go -1, so down, and back 2. And so I did that. And then I drew my line. So here, this is technical stuff, but it's really important. I do not want to see, this is how I'm going to know if you're paying attention to my videos. I don't want to see you just connecting the dots here, because really, these dots are just the highlighted ones. A line is made up of an infinite number of dots, so you have to put the line going all the way through, and then include arrows on both ends to let the person reading this graph, the reader, know, yes, these go on and on and on. We're just looking at a snapshot of it. All right, try this one. I want to make sure to point out to you, though, this negative. How is that going to change when you're defining your slope? See what you can do. And then, so pause, graph, and come back. All right, so let's see what you have. This one is trickier, like I said, because of this negative right here. So I pulled out my y-intercept, so I knew I was starting at 4, and I defined my slope. So slope was -3, so it could be -3 over 1, or it could be 3 over -1, because negative times a positive is a negative, and positive times a negative is a negative, so both of these equal my -3, which means I could go down 3 and to the right one, or I could go up 3 and to the left one. So I plotted my many points and drew my line, and the one thing I am missing are my arrows, because I got interrupted by students. All right, last example. Can you please, again, pause, just double check yourself. I know that some people might just copy what I'm doing, but I really want you to double check yourself. See if you can do this. And if you can't, where are you making your mistakes, and come check in with me. Okay, so here's what I have. I pulled out my 1 for my Y-intercept, so it's here, and then I pulled out my slope, so how I'm going to move. So I could go down 1 over 4, down 1 over 4, or I could flip where the -1 was, and I could go up 1, back 4, up 1, back 4. Now, if this was in a story, we could say maybe someone started with $1 and then lost a quarter every time they played a game, in which case this wouldn't make sense over here. But you have to think about that. In the stories, this is always your beginning point, and then this is what is being added to or taken away dependent on that independent variable. All right, that's it for this lesson. We out.